Hi there, my name is Matt, and today I'll be presenting project TASID. It's been a little side project of semester number 1 of 2012. The whole idea is that when a blind person navigates, they have to use a walking cane or an assistance dog to kind of navigate, and what the whole idea behind Project TASID is to eliminate that, maybe even improve on it. So the whole design, before I show you the prototype, is to have sonar sensors that will detect distances from the user to the object, and then that information will be relayed through a microcontroller to instruct servo motors or vibration devices, anything really in terms of tactical feedback back to the user. The cool thing is that this would work in 360 degrees. If you have sonar sensors around your head, you can also have these tactile feedback devices around your head as well, and as you get closer to objects around you, you feel different pressures around you. Okay, so without further ado, this is the prototype. So, bear in mind, this semester I am taking 7 courses and it's a fairly heavy workload, but I have managed to put something together. The whole idea being that right now it's in a glove, you have a sonar sensor in the front and a vibration motor in the back. I've actually got 2 here, one with a heavier counterweight that you can't see and a lighter counterweight right here. I'll explain that more in a little bit. And it's connected to a microcontroller, an arduino. And there's just a prototyping board up here and 2 9-volt batteries. So I'll explain the circuit a little bit. So the idea behind the circuit is the Arduino takes information from the sonar sensor, which is plugged in on this portion of the proto board, and the Arduino uses C programming to convert that into distances. So as soon as it passes through the Arduino, to paraphrase, knows the distances from the sonar sensor to the object. Now what happens is the sonar sensor sends out, this is the green wire here, this one, sorry, sends out a signal, varying voltage. I think it's 0 to 5 volts. 0 to 5 volts, yes, depending on how close an object is. Obviously, the closer it is, the higher the voltage will be. Now, the Arduino sends this in a PWM format, meaning that it's a square wave. It will go like this, like that, and the higher the voltage is, the higher the duty cycle is, meaning that the higher the voltage is, the more PWM translates into on more and off less. I'll have a picture up here. As you can see, the higher voltage represents more on time, while lower voltage represents less on time. Okay, back to the circuit. This needs to be fixed. This needs to be converted into analog signal. So what I have here is a low-pass filter, this resistor over here, and this capacitor over here. These two act to convert this square wave into a decently steady analog signal, a DC voltage, if you will. This is a single pass filter, or first order filter, so it's not perfect, but it does a pretty good job with a fairly low RC time constant. Now, this new DC voltage will get passed off to the op amp. I've got an LM324AN here, and so what I'll do is it will act in conjunction with this feedback loop I've got set up to amplify a voltage coming from the 2 9-volt batteries back here in series. So after it passes through the op amp, it's got a higher voltage, but the op amp can't handle a very high current, maybe around 20 milliamps. So this is where the power transistor comes in. It amplifies the current, i.e. total power. Once it gets past here, that's the final signal. That's what's getting sent to the vibrating motor, and this pin right here sends it off to the actual motor. The one thing that should be noted is right now the design is that only one vibrator is powered via this plug right here, or sorry, no, powered via the power transistor, but the other one is actually powered directly from the 0 to 5 volts source from the Arduino, being this cable, and that's the one with a heavier counterweight. The whole idea being that when an object is farther away, only the vibrator with the higher or the larger counterweight will be activated, but as it gets closer, the lower counterweight starts to get activated. Right. So enough of that. I will demonstrate exactly how this works. Okay. So as I get closer to an object, the vibrations, will increase. So as I scan around here and I wave my arm, I can now feel where objects are in relation to me. So out here, I feel less vibration than if I'm in here, and I do get a linear response from about half a meter to about 2 centimeters. So I guess I'm just gonna demo it here. The other cool feature that's added in here is if I touch the sonar sensor, it will turn off, and as you can see, if I let go, it will turn back on. This was a very early prototype. Not very much time was put into it, but it's a great proof of concept. This type of circuit can easily be made, I'm sure, shrunk down to an even smaller integrated circuit. As for future applications, depends how much time I have. Attached along with the video will be the code that runs this whole circuit and a circuit diagram with according feedback loop, values of the resistors, some caveats that you might want to be aware of when you're building a circuit, and the RC time constant. Yeah, the second thing that should be noted is that the Arduino isn't a perfect option for building a large-scale version of this. This is purely prototype level microcontroller. So I hope you enjoyed that small presentation, and if you have any questions, feel free to ask.